Okay, so we're going to try going over these samples. I got a sample A and a sample B, and then I think there's like 37 problems for us to do in the released questions from the state. So I'm going to start off doing the first one, which is you have to find an expression that's equivalent to the square root of 7x over 16. One of the properties of radicals is that you can, instead of taking the square root or the radical of 7x divided by 16, you can actually split it up. So there's a rule that says if you're taking the square root of a over b, you can actually take the radical of each item. So that's what we're going to do. So if you take the square root of 7x over the square root of 16, the square root of 7x can't do anything with it, can't take any square roots out, can't do anything with that. However, the square root of 16 is 4. Since I don't have any radicals left in the denominator, this is my answer. So that would be C. Okay, so that one's done. Alright, so let's go to the next one. What phi of x makes the square root of x minus 3 equal to 6? Alright, I'll show you the algebra way and then I'll show you the calculator way. Okay, so if you were doing this algebraically, the square root of x minus 3 equals 6, you would solve it like a normal equation. Like, had this been regular x, what would you do in algebra 1? Well, you would add 3 to both sides, and you have the square root of x is equal to 9. And to get rid of the square root, we do what's called the inverse operation, which is to square it. Just like you were doing the opposite operation of subtraction and addition, the inverse operation, or the opposite operation, if you want to think of it that way, of the square root is a square. And whatever you do to one side, you do the other. So x is equal to 81. Okay? If you were doing it by calculator, let me stop for a second and I will bring that up. Hold on a second. Okay, so if I were doing the calculator part, I would go to my y equals. I would type in the square root of x. Now remember that you want to close that, because otherwise the square root on the calculator will keep extending over the minus 3, and we don't want that. Minus 3. And then over here on the, let's see, I have to use this down there. I'm going to put down 6, and I'm going to find the intersection. So you can always do this on any of the equation problems throughout the entire test. If you have an equation, you can put it into the calculator, put the left side in y1 and the right side of the equation in y2. You're going to go to second, and you're going to hit calculate right up here, trace, and you're going to pick number 5. Okay, now the hard part about this one is that we can't really see where they intersect, and a lot of times the calculator does not like it if you can't see the intersection. So what you're going to want to zoom out. Okay, zoom 3, enter. You don't really tell. Not that you can really tell. That might give it to us. So let's try. So second, calculate, number 5. First curve, what I would do is, because this domain is kind of limited, meaning it's starting here, I would move this cursor over with, because it's sort of like leapfrog. It has to leap from one curve to the other, and you can see in a second if I hit enter, it jumps off onto the other curve. Watch. Took. See, now if that had been over, somewhere else and it couldn't jump over it, then we'd have a problem. Keep hitting enter. This time I'm not going to guess because I think there's only one intersection anyway. Hit enter, and this tells you basically, no, I'm not going to do it. So we're going to zoom out a little bit more, even though it'll look like gobbledygook to us. We don't really care. Alright, we're going to try again. Even though we can't even tell what the intersection is, it's got to be seen now, most likely. So we're going to hit second, calculate, and yes, this is a lot of calculator for a simple question. Alright, and it will jump on first curve. See, it's still doing it, it's just we can't see it real well. And look, intersection, and you can see that 81 is the same answer, okay, as we had there. So you can do it with graphing. You can do that with all equations. You can put one in y1 and one in y2 and solve it from there. Alright, I'm going to go to the next one. Okay, so I'll just prove that point. I'm going to do this one using I'm going to use, since it's multiple choice, I'm going to use the testing function of the calculator. So give me a second and I will hook that up. Okay, so I've got my calculator up again, and this is how you do this if you want to test answers. You go to y equals, you type in, now this is what I would do first because it's easy just to do. You're going to type in exactly what you see. Okay, 2x minus 4, close the parenthesis because I don't want the plus 6 to be underneath the square root, plus 6. And I'm going to go to test this. And if you notice, you'll see this little test over here. That's called, it's logic. And so what you want to do is test it, and see you have test, you hit equals because that's what I'm trying to prove, and equals 3. Now what it's going to do now is it's going to do, it's either going to give you a 1 or it's going to give you a 0. And in logic, 0 means no. So O means no and 1 means yes. So all I have to do is go to my, let me set up my table. So you're going to hit second and table set, which is the window button, and see where it says auto. See where it says I for independent. You want to change that one to ask, and you can do that. You put it on ask. When you go to your table now, it'll be blank, and now you can put in any values you want. So watch, I'm going to put in 5 halves into the calculator and hit enter, and see O means no. So problem number letter A is not right. I'm going to put in half. That gives me an error, which if you know anything about your square roots, if I put a 1/2 into this, that'll make this a square root negative, and we're not allowed to put negatives underneath the square root. That's imaginary numbers. That's why it's giving you errors. So tables will tell you when you have errors. I mean when you have imaginary numbers. And I'll put -1/2 in. And that's an error too. So what this is saying is none of these choices work. So this blank one is called an empty set or null set, which means there's no solution. And there is no solution to this. So that's how I would do that with calculator. If you were going to solve it the old way, I mean the real way, you subtract the 6. Whoops, that's kind of ugly, but you have this left over. My thing is kind of getting a little bit. Okay, so we have -3. Now you could stop right there and say, wait a minute, there's no way this is going to work because 3 times this has to be -3, which makes this thing right here -1, because 3 times -1 has to be -3, and there's no way you can generate a negative out of that, and that's why it's a null set here. It's no solution because we can't ever come out of a square root with a negative answer. Negatives can go in, but negatives can't come out with the real number system. Alright, on to the next question. Okay, what are the y coordinates of the solution to the system of equations? There's a couple ways you can do this one. Honestly, if I had the choice, I would just get this into y equals and solve. So what I'm going to do is I'm going to take each one of these equations and solve them for y. So my rule of thumb is basically if I'm trying to get rid of everything, I'll load it onto the other side. I just write its opposite. So I'm going to want so picture here's my equal sign where the 0 is. Everything that I want it all on this side now, so I'm going to change all of their signs because it takes the opposites to get rid of them all. You would subtract x squared, subtract x squared. You would subtract 6x, you subtract 6x. You subtract 6, subtract 6. Now notice I left the 3y because the 3y, I want to leave the y. But 3 and y are attached. They're attached by multiplication, so I'm going to divide to get rid of it. In fact, I'm going to let the calculator do all this work for me. I'm just going to put in the calculator as is. In fact, I'll put a parenthesis around it. So again, always do that because a calculator needs to know what to divide. Otherwise, if you leave the parentheses out, the only thing it's going to divide is this, and that was not what you want. Alright, I will do the same thing with the other equation. Put my equal sign down here. Anything that I want on the other side, I will change it to its opposite. And I want to leave the y alone. Okay, so right now it looks like I have a parabola. Again, you should be able to tell that from this guy right here. And this is a line. Because line, this looks like mx plus b. So we're going to put that in our calculator and see what that looks like. So hold on a second. Okay, so now I'm going to take my calculator and I'm going to put both of those things in the y equals. So remember parentheses, minus x minus 6x minus 6, all divided by, because I want to make sure I do that division right. Okay, I think I got that right. Yeah, looks right. Oops, I'm missing a squared. Hold on a second. I hate when I make mistakes like that. Second insert squared. Okay, I think I got that right. Okay, down, down. Alright, so I got that one set up right, and then I'm going to do minus x. What did I do? Wow. It's been a long night. Minus x. Go back. Minus. Jeez. Can we get any more tired today? Alright, so I got the two things in here. I'm gonna hit graph first to see what happens. No surprise, there's my x squared. Now I don't see my line. And the reason being is that right now my grade goes 10 by 10 by 10 by 10, and this says negative 20, so I don't see it. So I'm going to zoom out just to see if I can figure out what it is without doing anything else. Alright, so it looks like I got two answers. Can't really tell too closely, so I'm going to let the calculator tell me. So I'm going to slide this over out of the way. Alright, so what I'm going to do is I want to figure out what this point is right here, and I want to figure out what this point is over here, points of intersection. So what I'm going to do is I'm going to hit second, calculate, and I'm going to pick number 5. Now, what will happen is you'll see it's on the first curve, you hit enter, it jumps onto the second curve. Now you'll get this thing that says guess. Now, in order for you, the reason why you want to do that is because you really want to tell it you want this point over here, this point over here. Now, you can't read the x-axis. However, you know these are the negatives and these are the positives. So all you have to do is pick something like something negative over here, and it'll go to this one. So let's say I pick negative 5. Boom, see how it jumps right on there? Now look at my y value, negative 11. Well, I could keep going with this, but look, my choices are already negative 11, so I know this has to be the answer. Okay, so I could keep going if I needed to, and I would do the same thing with the other y, and it would give me negative 26. So I would keep going. Okay, this one. Now, what you need to notice on this, let me see if I can make a kind of a thicker line, maybe, or maybe a dotted line. Alright, you got asymptote lines going on here. You have one going on, looks like through the 3. Oh, my dotted line didn't work. That's okay. Okay, you got a line going in here, and you got a line going in, oops, along the x-axis. That's pretty ugly, but you get the idea. Alright, so this is x equals 3. Because remember that vertical lines are always x equals and horizontal lines are always y equals. So this is an x equals 3. So if x equals 3, that means that it's called what's called an excluded value. Okay, that means I cannot have 3 in my denominator, because if I do, that causes the fraction's denominator to be 0, and 0 is not, we're not allowed to divide by 0. So this is why this kind of line is here. So, and the basically the graphs want to approach it, but it can't, because again, there's no mathematics that can deal with the number 3 and this particular graph. Particular equation. So if we look over our equations, 3 is not allowed to be in the denominator. Now be careful, it's what x can be. Now here x is equal to, we don't want x equal to negative 3, so that's out. X is equal to 3, that's a good one. X is equal to negative 3, same deal here, and then we have another one here. So right now we have B and D as our two choices. The one more thing we're going to figure out now is we're going to figure out the horizontal asymptote. Okay, horizontal. Okay, wow, I don't know what I'm having little problems with my tablet, but anyway, that's supposed to say horizontal. Anyway, to find that, what we're going to do is we look at the degree of the top and the degree of the bottom, and we have 3 options. Okay, if the numerator beats the denominator, there's none. Okay, if the numerator is tied with the denominator, then we take the fraction a over b, and we'll talk about that in a second. And then your other option is that the numerator, the denominator wins out, then it's y equals 0. Okay, so we look at our choices. In B, the degree of the top is 0 because there is no variable. So the degree is 0, and here the degree is 1. So this is saying if the bottom wins, then y equals 0 is a horizontal asymptote. And sure enough, that's what that is. So this is my answer. Okay, right here. Now let me go down and prove that the last one we have down here, D, is not true. Okay, here the degree of here is on the top is 1 and the degree on the bottom is 1. Well, they're tied, so therefore I would follow this rule right here, and I would take these numbers that are in front, even though you don't see them because they're 1s, and you would make a fraction out of them. So that would make y equal to 1 over 1, which is 1. That's not where this line is approaching. Okay, it doesn't look like it anyway. Actually, now that I'm looking at it, I'm looking at it a little bit closer. I don't know. That looks like that line could be hitting 1. I don't think I really like this question. If we do that, let's see. This doesn't approach 0, but this one doesn't look like it's approaching 1. So I don't know. I might throw this question out. But anyway, if they're really arguing us of trying to approach 0, which this one is not, I would pick B. If they're going by this one up here, then I would say it is D. But I'm going to go with B for right now. I think that's what their major intention was, so I'm going to go with B. Alright, so we have this next one, which is basically, you could look at the graph if you want, or you can, it's what you know about your X and Y asymptotes. Okay, so if we have here, first of all, let's just do this without looking at it. The vertical asymptote, that means what makes the denominator 0? Well, what would make the denominator 0? X is equal to 0. Well, X equals 0 is, I have a graph describing the y-axis. Okay, the y-axis has the equation x equals 0. Okay, so you've just told me that basically the graph can't cross this line. If the graph can't cross this line, then that means there is no intercepts possible, because intercepts are what cross the y-axis. So if there are nothing's allowed to cross the y-axis, then there's no y-intercepts. So that leaves you with this one, and this one is a choice. Okay, my next question is, when you're trying to find x-intercepts, is that you have basically, if you are trying to make y equal to 0, okay, because that's what you do when you're trying to find the x-intercepts, and that's always true. If y is equal to 0 and you're working with a fraction, this part's the only part. Because if you think about it, the only way a fraction, if you divide it by anything, whatever it is, come out to be 0 is if this part is 0. Okay? 0 divided by anything is still 0. Okay? So what I'm going to do is think about x plus 1 being equal to 0. That's true. X is going to be negative 1. That's only one intercept. That's where it crosses the x-axis is at negative 1. So that would be this choice right here. Okay? If you don't want to go through all this math, you can go look at the graph, and we'll look at that in a second just to show you. Okay, so I have my calculator here, and I'm going to put it in the calculator because, you know, when push comes to shove, you can put in the calculator. Just remember to tell the calculator what you're actually seeing. Who's on top, who's on the bottom. You got to make sure you have that all correct. So that's what it would look like in the graphing calculator. Hit graph. Okay, now if you notice, it doesn't hit the y-axis at all. It's kind of tricky, but it really doesn't. It's going kind of bending and going right along the edge, and this thing's kind of bending, going right up here. So that's describing the vertical asymptote, which we talked about before. And if you notice that this guy's kind of hanging out over here, and it crosses right there and then goes down, this one just kind of hangs out. So it never really crosses the x-axis. So this is the one x-intercept we were talking about. So that's why C is the answer. So you have a little bit of interpretation of graphing to do, but I think you'll be fine. All right, I'm only on problem 4, and I'm at 19 minutes. So I've got to kind of speed up things a little bit. Alright, so which of the following describes the end behaviors? Alright, so we're going to put that in the calculator. I got to reboot my calculator, but because I'm using this kind of debugger calculator, and it's kind of quirky. So let me reset that up, and then we'll do this one. Hold on a second. Okay, so we're going to put this in the calculator and look at it. So again, make sure you put parentheses around your stuff, otherwise the calculator will give you a different graph. Alright, x squared. Okay, so let's go take a look at this. Alright, now it says here, which of the following describes the end behavior? So the end behaviors are literally the ends that are over here. What is this thing doing? What is this thing doing? And the calculator is not really great at showing a lot of this stuff. So you either figure it out, kind of anticipate what this is going to be, or you can look at your calculator. And so I'm going to show you a couple of ways you can do this. Alright, so you're looking at this thing and it says, do you approach negative infinity? Do you go to -6? Does y go to -1, or does y approach 0? Now, the idea here is if it's approaching and it's hitting this, it looks like the x-axis. Well, remember the x-axis has an equation of y equals, oops, I just lost my calculator. Is it dead? Let's see. Um, is it still there? Okay, good. Y equals 0. So that is what it's doing. So your answer is D. But let me show you in terms of a table. If you're like, I have no clue what they're asking. Okay, it says x approaches negative infinity. So what I want you to do is I want you to go to your table. Okay, and you'll see some answers here. You notice you see errors because it can't hit x equals 0. There's an error there. But we're going to go to our table and we're going to look up some high numbers. So let's look up negative 500 because we're going negative infinity. There, 511, that works. I hit the table and I'm at 0.002. That's pretty close to 0. I mean, if I had to look at all my answers, this one would be the best one. But just to make sure, we're going to go back to our table and we're going to go up to -1,000 or 2,000. Let's go crazy. -2,000. When you go to your table, look, well, this is scientific notation, but if you slide it over, it'll tell you, well, it doesn't. But basically, it's scientific notation means -4 means it's like 0.0005. So it's really approaching 0. So that's why you have that answer there. All right, so it's definitely not approaching any of these other ones, and it's not approaching negative infinity. Negative infinity would be down. This graph, let me go back to the graph so you can look at it. So if you're going towards negative, as x goes to negative infinity, which is off to the left, then y is certainly not doing that. Now, if they asked you what would happen if x is approaching 0, from over here, then it's hitting negative infinity because this line is just going down and going down and going down and going down. Okay, so let's keep going. Maybe. I already did that one.